Good morning, everyone. I will talk about the integral method to find the centroid of this shape. So first, I just want to show you that I changed the, um, the way I give the information for each point just to avoid confusion with the function. So this point will be the point A with xa and ya as coordinates. This one will be the point B with xb and yb, and this one will be the point D with x d and 0 for the y. And what we are looking to find is the centroid, the coordinate of the centroid C. So xc and yc. Okay. The first question I ask is to find the function, so this y1 of x, but also the function x1 of y, so to flip them. And this one will be just the y2 that is equal to like the ya or yb. Okay, that's just a horizontal line. There is no x function for this one. And this one, that will be the function that I call y2 of x. And after that, you flip all your functions, 3, sorry, to get x3 of y. Okay. So your first steps is to find those functions. So first steps, number 1, you find y1 of x, and after that x1 of y. This way you don't have any too much trouble. You will use y equal mx plus p. In this case, p is 0, and m, to find m, you use the difference between the y divided by the difference between of the x. Okay, so that will be basically the y a divided by the x a. Okay, when you get that, you flip that over and you find x1 of y. For the function y3 of x, a lot of confusion. You need to find the function from 0 with the same referential. So what we need to find is the function of this line there. That will be your p, and this one will be your m, your slope. So you need to find the mx plus p. P is not 0 in that case. P will be a number that is quite high. And how you find this, you will use the point B and the point D, and you will solve for M and for P. After you solve for M and P, you will switch all your number to find x3 of y. Be careful, you will move over the M. You need to, after that, you will move over first. Let me show you x3 of y. So let's say you find y3 equal mx plus p. You will have y3 minus p equal mx. So you will have y3 minus p divided by m equal x. This is not just 1 divided by m, it's like everything like this, okay? So at the end, you will have your equation x equal y3 divided by m minus p divided by m. Be careful because your slope is negative, so all your sign will be opposite. Okay, so that's the steps to find x3. Now you have this. Let's come back on that graph and let's look at, okay, I will clean a little bit all of this. We need this, we need this. So I will show you why we will use, that's A and that's B and that's D. Okay? We will use a rectangle that is horizontal, like this. This is the C tilde of this rectangle in the middle. So first thing, you need to find the area. Your area will be the integral of dA. And what is dA? dA will be the length times the 8. Okay, this 8 on that rectangle is dy. But what about the length? The length, distance between 2 points, you will use the x3 because we are on that function, on the purple function, and the x1 function. So that will be, and we want the center. So that will be another center. Sorry, we want the length. So that will be x3 minus x1 dy. That's why you need the function x3 and x1. And those two functions are in terms of y. So at the end, you will take the integral of a function of y dy, and y is going from 0 to your ya or yb. That's for the area. Now for the x bar, you need the integral of x tilde dA. Okay? So we need to find x tilde. So x tilde is the center of that rectangle. This one there, x tilde. So to find the center, you do the sum of both points divided by 2. That will be x1 plus x3 divided by 2. That's how you have this function and this one. And you divided everything by the integral of dA, okay, just to make sure after. So this function there will go there. dA, you already have the dA, you found it before, okay, so this dA there is this one. So you will have at the end the integral of x1 plus x3 divided by 2 times the x3 minus x1 and the dy from 0 to your ya. That's for x tilde, okay? That's for x tilde. For y tilde is way easier because y tilde in the middle there of your rectangle is just y. Okay, this is the same y everywhere there. It's just y. So to find your y tilde, you will have the integral of y. To find the y bar, you will have the integral of y tilde dA divided by the integral of dA. And this one on the top will just be integral of y times dA. Again, the dA, you take the same dA. So that will be integral of y times x3 minus x1 dy. And you divide it by the integral of dA. And that's the same thing, that's from 0 to ya. Okay? I put a little bit everything everywhere, but remember, do those steps first, and after that you can go on the integral. To find the value of the integral, use your finite integral in your calculator function. Or you can use Desmos. I will give you access to Desmos also for your final exam. So let me know if you have questions. Try this. You should absolutely find the same value for x tilde, x bar and y bar. So x bar and y bar, you should find this exact same value that you found with your composite method. If you want, you can check that you have the correct value. Send me your value in WebEx and I will tell you, yes, they are correct. You can keep going. I will be happy to give you that information. So I hope that makes sense. Tell me if you have questions and working on your grading, but may not be completely done today. Have a great day. Bye-bye.